Alright, so we're looking at an average velocity problem with different time intervals. There's an interval where the driver is driving at 72 miles an hour and an interval where the driver is at rest. And we need to combine those into an entire trip. As usual, you should attempt this problem before you watch the video. I'm going to go ahead and get started and write down what we know and what we don't know about each segment of the trip and the total trip. Okay, so we'll say part 1 is the part where the driver is driving and the speed is 72, but we don't know delta x and we don't know t. Part 2 will be the part where the driver is stopped, so there's no moving, velocity is 0, and the time is 0.25 hours, 15 minutes. And then for the total trip, we don't know the total distance traveled, but we do know the total average velocity is 66 miles per hour. And we don't know the total time. So what to do? Well, we know for part 1, we know that delta x1 is equal to 72t, but that doesn't really help us because we don't know either one of those. For part 2, we know that delta x2 is just 0. And for part 3, we know that delta x total is equal to v total times t total. But I'm going to take advantage of this equation. I'm going to rewrite it as v total is equal to delta x total over t total, which is the sum of the two displacements. Okay, so this little trick is going to enable me to solve the problem, because I know what v total is. I know that 66 is equal to delta x1 plus delta x2 over t1 plus t2, and I know that delta x1 can be written as 72t1, delta x2 is 0, and then t1 plus 0.25, right? So you see now I've got this as a single equation with a single unknown. I can cross multiply to start to solve this, and that gives me 66t1 plus 16.5. So 16.5 is equal to 6t1, and therefore t1 is 2.75 hours. Well, now that I've got that, the whole problem unravels basically. I know that delta x1 is v1 t1, which is 198 miles, and that's delta x total, right, because delta x2 is 0, and so delta x total rounding off is 200 miles.